Okay, I think we can start the session about webRTC in FileMaker. Maybe a quick question. Who did already hear about webRTC before? Okay, some couple of people. Great. So I hope I will be able to learn you something today. If not, okay, it will be fun, I guarantee. So first, really quick about myself. I'm from Bruges, Belgium. Full-time certified developer, certified till 19. Nowadays, I have all that badges, so great. Proud member of the ClickWorks team. I really like pushing FileMaker to its limits, like technical challenges, and in my free time, I like playing volleyball. That's about me. Volleyball, yeah. Okay. What will this session be about? First, yeah, for the people that didn't know about that do not know about webRTC, I'll explain what it is really quick. Then we will see how it actually works. So we will deep dive in the webRTC stuff. Because you need some kind of signaling thing going on, we need an event listener in FileMaker. I'll made that, so I'll cover that as well because it's a FileMaker conference. It would be cool if we can do some code review. We'll see if we have time for that. Go over some use cases and stuff I learned during the time I worked on this, and of course, time for Q&A. So, what is it about? What will this session be about? So, actually, I found out only 1 year ago. So. Maybe I'm a newbie in this topic, but I found it that interesting that I wanted to give a session about it. I discovered so 1 year ago I was, or still am, in the ETS for FileMaker Pro, and I saw this new feature coming up to test 4.4 webRTC support for web viewers. At that time, 1 year ago, I never heard about it. So, but the title was cool. Okay, web viewers now support web real-time communication. So I started digging, started reading about it, checking YouTube movies, and yeah, what is it about? So the title says it almost already. It's just real-time communication between web viewers, or in general, web browsers. But in our case, we are FileMaker developers. We have our web viewers. So it is not really something new. It's only supported now in FileMaker, in the web viewers. So because webRTC was launched in 2011, I think. First stable version was 2018, but it's around for some time already. So what is it? Let's go to the docs really quick. So it's real-time communication. It's an open standard. The open standard is JavaScript, so it's really part of the JavaScript library you have in your web browser. Mainly used for video, voice, or data to be sent between peers. The peers is a web browser. But the web browser can be on your iPhone, on your Mac, wherever you want. So it's available in all modern browsers because it's part of JavaScript. It's open source, but it's maintained by Apple, Google, Microsoft, all the big guys. So it's about real-time communication in the web browser. Sending streams, so we'll come back to that later. Sending or creating a peer-to-peer connection from one web viewer or one web browser to another. So in the old days, let's say you had client 1 and client 2. If you want, for example, do peer-to-peer communication, what were the options? You needed a server in between, your web server, for example. Client 1 sends his data over to the server relays it back to client 2, and vice versa. Client 2 sends its streams to the web server, and so to client 1. And that was how live communication was done before 2011 or 2018, before webRTC. Of course, this brings some problems. You need that web server. there will be a lot of data because it's mostly used for video chat, audio, that sort of stuff. So there's a lot of data going through that server. So there's also, of course, a delay if you first need to send it to a server and then back up, and vice versa. That you can be maybe here, Malmö, the server is maybe in Frankfurt, the other client is maybe at the other side of the world, or maybe even here in Malmö, but you need to send the data, you get the picture. So there's delays, there are security issues. What if you don't want, because the data has to pass that server, what if somebody do something on that server? So there are problems with this architecture. So that's why they invented webRTC. We won't longer need that relaying server, but we will instead create a direct communication from one web browser running JavaScript to another web browser or web viewer in our case, also running JavaScript. And we will be sending data directly from one to another without the use of any server. It's not entirely true without the use of any server, but we'll come back to that later. Let's just show a demo. I have Joris here today as my assistant. So just as a quick demo, I made this sample. It's not yet available on the OneDrive because I made some, like every good presenter, made some last-minute changes, so bear with me. They also told me to, no, not last evening, but last week. So, but we tested it, so, but it should be fine. They told me not to do live demos, but that's what we are going to do today because, I could make some movies, but okay, we're talking about live communication, live streaming, so I think it will be lame to do some video recording. So let's do it live. So I made some couple of examples. We'll start with a whiteboard. I'll create a new session. Of course, you need to create some kind of session that other people can join. This is what now happened. I created this session. Joris also has the same file. It's just hosted on our dev server, clickwork.eu, I think in Paris. You just saw a new user popping up. So Joris is now apparently drawing something in his web viewer. So Joris has the same screen that I have. You can look, but I can also draw in this web viewer. Hi, and we can work together. So we are now actually sending data from his web viewer over there directly to my web viewer without the need of any other service at this time. The only need for an external server is when he, hey, you're erasing my stuff, hey. First, we of course need to do some handshaking, and I will go over that later in the session, but we need to say, okay, you are there, I'm here, let's work together, let's send the streams over. And therefore you need some kind of server, but the good news is we are FileMaker developers, we have a server. So, okay, but let's come to that later. So we're actually sending now live data back and forth from one web viewer directly to his. So that is webRTC. But this is, for example, a stream of a canvas. But later on, we will really literally create a video chat app as an example. So this is my first example. Let's go back to the keynote. So WebRTC. Let's say I will now go further on the WebRTC stuff, but the easiest way is to do it with an example. So let's build together a video chat app. What will we need to have this working? So we'll go over some WebRTC concepts, and I'll explain you on the go. So let's say we want to build a video chat app. We have client 1. In our case, a web viewer in FileMaker, and we have client 2. But actually, it doesn't really matter if it's a web viewer, web browser, on an iPhone, Android. WebRTC will take care of that. If you maybe on an Android machine, you have other codecs, other camera stuff. WebRTC will really take care of all that. So that's really great. There are 2 big things we need to do. First thing, I will refer to GUM or get user media. This was already possible before FileMaker 2021, 2024, or version 21. This is a function in JavaScript to ask for the media. I ask for the camera, audio, or your screen sharing. And the second big part will be to create a peer connection. So it's peer-to-peer communication. So there will be some kind of peer connection, and that's actually only a JavaScript object in your web viewer that will hold all the information about the webRTC session. So you can see it as a little dot here. It will be a JavaScript object living in your web browser. We will also have it at the other side, and we will work from that. But maybe I'll first focus on the get user media. This is not actually part of webRTC, but we need, if we want to build a video chat app, we need the video stream of the user. And to show you that, I'll do some live coding. I know that's not very good, but let's do it. Just to show you how easy it is. I will call this file get video.html. Okay. And of course, nowadays we code with Copilot, and I tell him I want an HTML doc with one video element. Okay. That's how it easy is nowadays. Okay, I'll accept this. We'll review the code. Okay, I have a HTML doc. He created one video element. Great. With this size, that's okay. We won't need the source because we will add our stream later on. And okay, I will save this. Where did I save it? I think in my documents folder, probably. No. In my Jan STP folder, yeah, Git video. Okay, we'll open this one just to check. Okay, we have a video element, but we don't have our stream yet. So what we want, I just want to show you how easy it is to get your stream. Bear with me, it won't take more than 1 minute extra normally. So of course, it's part of the JavaScript, so we will need to add a script, and we will first refer to your video element, const video. He already knows what I want to do. Yeah, so I'll grab our video element here, and we put it in a JavaScript object so we can refer to it later. Okay, great. Now we want to create an asynchronous function called get user media, for example. And he already knows what I want to do. Great. Okay, let's, yeah, it's not really coding, I think, but okay. But it's nice, though. So what he did, it's an asynchronous function. Why? I'll explain very quick. The browser will ask the user for his camera, but he can say no, or he can wait a little bit. So we need to wait. It will run asynchronously in the browser. So we will await, and this is actually the only function we need. It's in the navigator, so that's part of the window. There's a method media devices get user media. And then here we can pass some constraints. In this case, I only want the video. I can also say, okay, I want this size of video, or I want the audio as well. We won't add the audio because we will have loopbacks otherwise, but in this case, I only want the video. So actually, it's only this one line of code that will get our video. And we will put our stream that we get back in our video element here. That's it. And only thing I want to add is video play to start playing the video. So this is our function to get the user media. And of course, I will need to call that function at startup. So let's save this. Let's go back. I'll refresh the page. And now he's asking me for my camera. Okay, I want to use your camera. Okay, allow this time. And now I see my light blinking, and there it is. So that's how easy it is to get somebody's camera feed, put it in a stream and JavaScript, and then we'll be able to use this stream to pass it with webRTC. So this is the first big part of webRTC, is just to get some media if you want to build a video chat. But this is how easy it is. And I'll show you even more. But there's also a second function, and it's called get display media. And, oh, I closed my browser, stupid me. Go back, P. So now I change it to get display media, and now it's asking which window or screen I want to share. So it's actually that easy to share your screen in nowadays. And now I'm sharing my entire screen, and I have my screen sharing in my stream. So this is what we will use later on in our webRTC stuff. So that's the GUM, the get user media part. So just showing you. This was already possible before FileMaker 2024. I'll have a little example here, get user media. This is the code we use. But what you can do with that, so in FileMaker, it will ask you something like this. The web viewer want to access your camera. Okay, I'll need to click allow, of course. Now it's checking my camera, and the same thing will happen. Normally, yeah, this is just the same as before. The only thing I added here is there is this take photo. This will actually take the photo of the stream and put it in a FileMaker container. So this was already possible before 2024. So this is the navigator, media devices, get user media. This is just a quick example. It works on Windows as well, so it's because it's on top of JavaScript, it works in more or less every browser nowadays. There are some caveats, but I'll talk about that at the end of the session. So, two big parts, get user media, we covered that, great. And then we will create a peer connection. So a peer connection is actually part of the webRTC stuff that is now part of JavaScript. And it's a simple function, create new peer connection. And that JavaScript object will hold all the information necessary to create that webRTC direct link between the two web browsers. So one thing to say is that webRTC always uses UDP. You probably heard of that. UDP instead of more common TCP, like HTTPS uses TCP. What are the advantages of TCP? It's reliable. If there's a package lost, it will resend it. So it's stable. It has acknowledgement built in, all that sort of stuff. But in our case, it's using UDP. And why is that? It's just fast. It's reliable, but a little bit less reliable. Because if there's a package lost, okay, then it's lost. But this is what we want. We don't want, for example, if you're in a video chat and you have bad Wi-Fi for a couple seconds, okay, you will miss the meeting for 2 seconds, but you don't want, when you have Wi-Fi again, that it keeps resending the old packets. No, you want to pick in where the live meeting is at. So, okay, you will miss a couple packets, or the quality of your video will maybe go down, but you want to be live. So that's the great advantage of UDP. It's fast, and yeah, that's the main advantage. So could you use webRTC to send files? Yes. Is it desirable? I don't think so, because yeah, you never know if everything was sent. So okay, it's using UDP. Now I'll go just over the steps that are necessary to start up a webRTC session, let's say. There are actually two questions we need to answer. The first is, okay, where am I, and where, more important, where is the other client? We want to stream stuff over and back and forth, but where to? So that will be the first question to answer. And the second one is what will we be sending? Maybe yes, person one is on an Android phone, has this camera, the other one is on a Mac. So we will need to discuss and say, okay, this is what we're sending back and forth. The get user media is already a little bit, we'll answer a little bit the what, but it's later on. So the first thing will always be get the user media, because yeah, we will need that, of course, to send over. Then we will create that peer connection. It's just a JavaScript function. I will go over the code really quick if we have time. You'll see just create new peer connection. This creates that little yellow dot over here, for example. And we need to pass stun servers to that peer connection. Okay, first scary term, stun servers. What is a stun server and why do we need it? So this will actually resolve the question, where are we? So isn't it just possible that client 2 gives a public IP address to client 1? No. In the 80s, they decided that they created IP4 and that 4 billion IP addresses would be enough for everybody, but apparently not, because there are more than 10 billion devices nowadays. So there are a couple problems. They can be, there's network address translation. They can be after a firewall or on a VPN. So there's no way to directly pinpoint that web browser. But this is where the stun server comes in. What is the goal of a stun server? Okay, yeah, you can be after a router. There are multiple clients behind one router, like we are here. We all share the same public IP address, I guess, but we are here all with more than 100 devices after that router, so there is network address translation needed there. So what is the stun server's goal? It's actually an external server, and we will use Google servers. Google has a couple stun servers you can freely use. The only goal of that stun server, stun stands for Session Traversal Utilities for NAT. Okay, you can forget that. But the only goal of the stun server is, okay, I will ask the stun server, trace me a route back to me and tell me how you did it. And it will give you an array of possible ways to you, because there can be multiple ways, like on TCP, on UDP. There are multiple ways, or you can have multiple IP addresses sometimes, from time to time. So it will be an array. So it will give you back ICE candidates. Another scary term, but it's actually just a JSON object, an array with multiple ways to your browser, to your IP, but yeah, even more, yeah, the actual browser you're in. So it's a lot more. I'll show you the JSON object. It's not that much, but it's a standard, of course, they use for that. So we have the peer connection. We passed it to stun servers, and this will give us back ICE candidates. The ICE candidates tell us where we are. So that's already answering a little bit the first question. Then we will add the tracks to our peer connection. Tracks is just the stream, actually. In our case, it will be video. It can be video and audio. So video and audio is a separate track. It can be just binary data. It can be, yeah, so like webRTC is also used for gaming, like gaming information, real-time data. It can be arbitrary data. So most of the time, it's a stream. But the stream can consist of multiple tracks. So we will add the tracks to our peer connection. So the peer connection is actually what is, yeah, defining or peer connection, yeah. And then there is a method to create an offer. Another term, but I'll explain. There are two parts in an offer. It will set an RTC, so real-time communication, session description. And what is in that session description? It has a type. It's also just a JSON object. I'll show you an example in a couple of minutes. And it's of the type offer or answer. There is always one client that decides, okay, I want to call you, or I want to start this session. It is what I did earlier. I started that session, and you already joined my session. Somebody has to start it. If you do a Teams call, you are the offerer, and the other person will do the answer. So it's a type, and there will be some session description protocol. That session description protocol is actually answering the what we are sending. It will describe which codecs we will use for video, for example, which security which encryption we will use for the communication, that sort of stuff. And that's answering what we are sending. So we know where we are, we know what we are sending, but of course, we don't know where the other person is. Okay, all that stuff we will set in our local description. So the peer connection has a local description. It's actually this information, the type, and our SDP from ourselves. And we will also have the set remote description. Later on, we will put the type and SDP from the other client into the remote description. So that's only what is about. So this is an example of that RTC description. You see the type is offer, it's just JSON. And in here, SDP, it has some information. I don't know either what it's in, but the stream type, the security things are in there. But not to worry about that. It's just an object, and we need to pass it to the other side to let them know, okay, this is which codec we are using, and so forth. And this is our examples of ICE candidates. I was on the train, so I had some weird 172 IP number, but I had multiple. You see UDP here. So apparently this was a UDP, but this is the TCP connection to me. And this can change. So it's an array. But we pass those stun servers to that peer connection. But it can be, if I'm on the go, that my IP address changed. So at that time, it will give me new ICE candidates. But if you stay on the same location, this won't change. But it's an array of possible ways to you. It will say which port and etc. I don't know what is in there, but it doesn't really matter. We get this back. The thing is, how do we let the other person know where we are? So we need some kind of, so that's where I lied in the beginning. We will do the streaming without a server in between, but we need some kind of mechanism to let the other person know, okay, this is where I am, and this is what I'm sending, and that sort of stuff. And that's where we need a signaling server. In web environments, they will always use the WebSockets for that, a WebSocket IO server or something. But because we are FileMaker developers, I use the FileMaker server to pass that information on from one client to another. Both our clients are connected to a FileMaker app. So we are both connected to the FileMaker server. So we can easily use that FileMaker server. It's just those two JSON objects. We just need to, it's actually those two JSON objects we need to pass from one client to another. So it's not more than that. So how will this work? Of course, they are connected to the same FileMaker server. Client 1 will push the offer and ICE candidates to the FileMaker server. Before I I created some kind of call record, because I want to call Joris, for example. I created a call record in FileMaker from to user, and then I have 4 fields, one for the offer and ICE candidates of the caller, and one for the answer and the ICE candidates of the answer. So it's just that simple. Of course, the FileMaker server need to pass that offer and ICE candidates to client 2. Then we have the whole same system again. At client 2, we'll need to get his user media, create that peer connection, that yellow dot over there, pass some stun servers so he can figure out where he is. He will add his tracks to his peer connection. He will set his own local description. That's that SDP and answer type. The type will be answer, of course. It can already set the remote description. That's actually that offer will go in the remote description. So actually now, client 2 already knows enough to do the connection. It has its own information and the information of client 1. But of course, client 1 does not know yet where client 2 is. So client 2 will put it answer and ICE candidates that it got back from that stun server in call record and pass it on to client 1. And then something magically happens. Oh yeah, client 1 need to set that all information, the answer and ICE candidates in the remote description, and then something magically happens. It just happens. We will see in the demo. it just works. How? I don't know. It's just webRTC. They know how to communicate. I just explained, but it's magic. So with further ado, let's go to demo. Joris, open your demo app again, I would say. So I have two examples, video chat, screen sharing. It's actually just 2 times the same, but with different get user media. Or I get the user screen or camera, or it's screen. So I see here online users. I just have a user table with Joris in it. I'm in there as well, but I hide myself because it has no point in calling myself. So I can now call Joris. This will launch a FileMaker script. This will create that call record. I'll show you in a minute. And then it will start the whole JavaScript part. We'll go over the code if we have time. We'll see. So now you see it wants to get my camera. It's getting there. It takes some time, a couple seconds. So now I have, and maybe Joris. Yeah, so now something magically happens. And that's where that event listener for FileMaker comes in. Of course, I need to say, Joris, hey, I want to call you. So I have some kind of event thing going on that tells Joris, oh yeah, Jan wants to call you. Do you want to connect? And then if Joris, yeah, you can click connect. Ah, yeah, you need to allow access to your camera, of course, yeah. You only need to do it once. So you saw I didn't need to do it here because I already did it in the other example. So now it works. So we have now live communication going on from my web viewer to yours web viewer. So yeah, that's it. So you could do Teams calls in your FileMaker app if that's really wise to do. I don't know, but same thing for screen sharing. But maybe screen sharing is more, yeah. That's the second part of my session. It will go after this demo. Maybe Joris, now you can call me. So we'll see what happens. Yeah, you just click on me. Then it will ask what to share. You can choose your window, your whole screen. If you have multiple screens, it's part of your OS. So now I magically, so this is the event. I'll explain to you later. Magically, some script is triggering on my side. Okay, Joris is calling me. Do you want to ignore or connect? I'll say connect. What does it mean? Okay, I will also share my screen with him. That's not really necessary, but in this case, okay, we'll share our both screens. So now we have the same thing. Yeah, it's of course looping, but I'm scrolling. Yeah, we're sharing, and yeah, okay. But you get the picture. So so maybe move your window around. Can you? Oh, yeah, we see his mouse moving. Yeah, you are moving your mouse there. Maybe move your screen or something. Yeah, okay. You see that is Joris there. Okay, yeah. So that's Joris' screen now. So that's how easy it is. Okay, so that was the real video chat app we built. Okay, we didn't really build it, but I explained to you how it works. All this code is available, so all the JavaScript will be available. This sample file. We'll, if we have time, go quickly over the code, but we'll see. More important, how does that triggering works? I want to call Joris, there's something magically happening that a script runs on his client when I want to call him. So I'll explain that now. This is what normally in web environments, this will be done by the socket.io server, but because we can here in FileMaker, I built something in FileMaker. Is it wise? That's something else, but yeah, we'll see. So we have client 1, client 2, both connected to the FileMaker server. That's necessary because yeah, maybe back in 2014, my kids were smaller that time. They're very cute, but I had my first dotFMP, and I presented something, also client-to-client communication. And then I used the onRecordLoad trick. So if you have just a record sitting there inside in a temporary window or something, and another user deletes that record, on that time the onRecordLoad script trigger is fired, and that's some kind of triggering somebody else. So that was a trick I found, oh yeah, that's cool. I can create some kind of client-to-client messaging app with that. At that time, the only use case we had was creating PDFs on a robot, because we could not create PDFs on the server yet, but we could have a robot sitting there and trigger that robot. Oh yeah, you need to create a PDF and give it back to me. So that was the only use case we had at that time. But okay, it was more like Stieperaere. You can still find the document, the link on our website. Nowadays, my kids are still cute, but a little bit bigger. So we're 10 years further, of course. So I have I found a new system. How does it work? At startup of the app, so the demo app in this case, we launch a perform script on server with callback. But we don't do the callback. We just let it sit there, waiting. And then you can, let it there waiting and put it in a loop. Just put it in a loop with 1 second pause or something, and just let it sit there on, for example, in my use case, it was the user record, my user record. And the moment I want to trigger Joris, so client 2 wants to trigger client 1, what he does is he just set a boolean. Hi, I want to trigger you. I want to, or call you, or whatever. And the moment I set that boolean, the callback is done. So actually the callback is just waiting there. And the moment I set a boolean or do something else, create a record, a related record, that depends on how you want to use it, it performs that callback action. So then you can handle that callback that is then fired. And I created an event table where I say, okay, I want to call you, I want to answer you, I want to send a message, for example, in that demo file. So it depends what you want to do, of course. But then you do the action, and of course, you need to relaunch a new callback script on the server and just let it wait there. So that's how I did it in this example file. Is it wise? I don't know. It's a little bit of overhead, of course. There's constantly a session running on the server for each user. So it will work the same, of course. So how it works, you register your user at startup. You have a script that just listens, but it's just a loop 1 second. For example, every second it checks if there's a Boolean set or no, for example. Then you have that listener script, the process event script, the script that needs to check, okay, what do I need to do? And then you have a stop listener script. That's it. Of course, you have then a listener for every user that you have on your server. I tested it with more than 30 clients. It's really like 30 listeners. The CPU was still at 1. I don't think it's really heavy because it's just sitting there, checking that Boolean, for example. So is it ideal? Maybe not, but I could do it in FileMaker, so why not? Demo time, yeah, maybe quick. It's the same thing. It's the last demo in my file. So I built a kind of messaging system. I can send a message to Joris. Hi, Joris. And now if I hit enter, we trigger the server and Joris gets a message. I just show a dialog box because it's just doing, but Joris can also send a message to me. Maybe just to, whatever. Just make. So there's just a script waiting there, and once it sees, okay, there's something to do, he hits enter. There's 1 second delay. Hi, buddy. Okay. So then it triggers that script. So that's how I did it. Okay. That is that. I only have 5? No. 20 minutes. Okay. I'll quickly show. It won't take more than 5 minutes. But I want to show you the code just to let you see how easy it is. Of course, it's easy if you know how to do it. That's always the same thing, I know. But maybe with this session, I'll also share you what resources I used. There are good YouTube videos on the web. But I'll show you the video chat code just to show you, okay, how easy it is. So there is, of course, some CSS and things going on, but okay. In this case, I only had 2 video elements, the one for the local, my, and the remote and the local. Just 2 plain video elements in my body. And I had a hang up button to hang up the connection. That's the body. Then, can everybody read it? Everybody read it? Yeah, I suppose so. So in this case, we have 2 video elements. So I have the reference to the local and the remote video element. It's just grabbing or element or video element by this ID. So the element is actually the element in your body. The stream, the local stream, will be the actual video and audio stream. So this variable will hold our stream or local stream and a remote stream. They're both empty at the beginning. We define them globally because we need to set them within functions, so we define them globally here in global scope. We also define the peer connection. There will be a Boolean, did I offer? It will be important to know at one time, am I the one that offering the connection or I'm the answerer or not? Okay. And I created a global call ID that's actually the record from my call record from FileMaker, because I need to set there that SDP and that ICE candidates in that record. So that's why I have this global variable. Peer configuration, this is what we will add to that create peer connection later on, because the only mandatory parameter there is that ICE servers. And in this case, we use Google's, the 2 Google Stun servers. They are free to use. So we need to pass that to a peer connection because that's part of the webRTC. We need a Stun server. But like I say, they are free to use from Google. So I'll hide this one. And then we have a couple functions, and I'll just go over them really quick. So not that much, and they're all pretty straightforward. The hang up button just closes the peer connection, really straightforward. And this is the event listener for the click on the hang up button. So these are really easy. Maybe in chronological order, we have the call function. This will initiate the call. So this is when I click the button, create call, it will create an event, a call record in FileMaker, and then it will call this function in my browser. There is a function to answer the offer. This is on the other side then. And then there's the add answer. That's again on client 1 when we need to add the answer back to our peer connection. So only these 3. The fetch user media, this one we already saw in the other example. It's the same thing. We get the stream, media devices get user media, and we put it in our local video stream. That's it. There's nothing more to it. So that's the same thing we already saw. And then there's the creation of that peer connection. So, okay, but maybe go over it in chronological order. We start the call. What happens when we start the call? Okay, we get our call ID. This is actually started from FileMaker. We pass that call ID, the ID of that call record. First thing we do is the fetch user media. So we fetch the stream. That was that other function we already saw. And then we will create that peer connection. I'll just go over it really quick just to show you. It's very simple. Peer connection, await. It's a new RTC peer connection. So this is a function of webRTC. And we pass it that Stun servers, that configuration, those Google Stun servers. And we already create a remote stream that will be filled up with the remote stream when it comes in. For now, it's just an empty media stream. And we already put it in that video element, remote video. There is no stream yet, but we created it. That's just happening when we create our peer connection. And then the second part was add tracks. That's what we do here. So for each track in our local stream, we will add that track to our peer connection. There's a method add track, and we added it to the peer connection. So maybe I can show you here real quick. So we are We are already here. We get user media, peer connection. We created peer, we passed the Stun servers. ICE candidates will go to, we added the tracks now. Next thing to do is creating the offer, but yeah. So tracks is adding a track. So a stream can consist of multiple tracks. So in our case, we only had a video track, but we can have video and audio, and we can have multiple tracks in one stream. So for each track, we add it to the peer connection. Yeah. And then that peer connection will have some listeners. This one is not really important, but this one, ICE candidate, is really important. Okay, every time we get an ICE candidate back, this is what we will do. In our case, every time we get an ICE candidate back, we want to pass it to FileMaker. So I have a function in FileMaker, perform script, set ICE candidate. And I just pass it two parameters, the call ID, in which call am I talking about, and this is the ICE candidate. So this little part of that array of ICE candidates, because it will come in as they come in. If he finds a new route, if you're on the train, or then maybe 5 minutes later, it will give you another ICE candidate to get a connection to you. So you can just stay updating this, and every time this updates, we will pass that ICE candidate to the other user. So he can keep your connection alive. So this is what happens when an ICE candidate comes in, and then also an event listener when a track from another user comes in. This is not really, yeah, and we will set it to the remote stream. So this is the creation of the peer connection. And that's actually it. So we created, fetch the user media, create peer connection. Now it's time to create our offer. So it's just also a function within webRTC. You give it's a function of your peer connection method, create offer. It will create that SDP, because we already added our tracks. It knows which video, which audio we are sending, and it can create that JSON object with that type of offer in this case, and then all that information about what we are sending. Yeah? And we will put this in our local description. And then we are sending this also over to our caller record in FileMaker, and we put that offer in that record. And then in that FileMaker script, I have the function to call the other side. And then that whole same thing happens. It's a little bit different. It's the answer, of course. It will do all the same thing. It will fetch the user media, create a peer connection at their side. It will create an answer, of course, not an offer, but an answer. Set the local description with answer. And it will just do the same thing and pass it back. And then we have the last function here, add answer. That's again on client 1's side. It will need to set the answer from client 2 in the local, the remote description from the peer connection on client 1. And then something magically happens, and you have the stream working. So it's just that. So okay, it's a little bit of code, of course, but just to show you, you find examples on the web. Of course, yeah, I spend a lot of time finding out how it works, but I think it's really, really nice to do. It was really nice to do. I didn't keep track of that, so sorry. But I live in Bruges. Our office is in Antwerp, so I go there only once a week. But every Friday, I have 1.5 hours on the train. I could spend to do research, test stuff out. So I'm literally doing now 1 year of research. I already presented a little bit of this in Berlin in June. But yeah, I don't know how many hours, but okay. But I didn't have Copilot at the time. So now it's crazy because the streams, it's only also, for example, if you want to record your stream, it's also one function: start recording, stop recording, save recording. So that stream, and you directly get your recording. It's great. I just didn't know that it was all that easy. Oh, easier. It's crazy what you can do nowadays with all that stuff. Okay. Code review. We did that. Yes. Okay. So all the code I did not upload it to the OneDrive yet because I made some changes. Are there any questions maybe already? Yeah. Oh, Mike. Yep, go ahead.
What happens if Joris is not online? Do you have some kind of timeout, or it keeps
No,
rolling.
but I could do it is in the script that's, yeah, this is all FileMaker, of course. You need to build it yourself, but you could build in some timeout if he does not. Now I show a dialog. Maybe it's not good to show a dialog because then you're blocked. But do something else and then do a loop and wait 5 seconds. If he didn't answer, pass it back and say, okay,
But
he's not there.
you don't know if he's online or not.
I do, because, yeah, now I did because I keep track of the active users. If I close my demo file, I will unregister myself. I will delete myself from that user table. So I'm no longer there. So Joris won't be able to call me. So maybe, yeah, Joris, if you, I don't know if you still have your example file open. If you close your file now, it will delete. Yeah, just close the file. This is a portal, and then Joris is gone. I can no longer call him because he's gone. That's how you build it. It's FileMaker.
Cool.
No magic there. Yeah, maybe pass the mic on. Yeah.
Hi, great session. Thank you. I just wanted to ask, what is the process when the stand server changes? Because you have like that event listener,
Yeah.
and it updates. You said that it updates with a new stand thing, like getting your new address, let's say.
Yeah.
Okay. And does this need to get back to the other client as well? Because
Yeah. It's just an update, so I will update that record, my call record. But if you want that it gets passed, you also need to pass it to the other.
okay, so
Yeah, you need to trigger it.
When this gets updated, that you trigger a FileMaker script.
In this example, I don't, because, okay, I assume that we stay on the same location. So, but if
Okay,
you want to
okay.
build it bulletproof, you will need to pass it on to the other, pass that new ICE candidate, and it will register
Nice,
it, and
ICE
then
candidate.
it will just keep on working. Yeah.
And then the client too needs to update with that ICE candidate
Yeah.
to
Yeah.
his
Yeah.
remote
Yeah,
session.
you just add it to the peer connection. So when a new ICE candidate comes in, it updates it in the peer connection.
Okay, okay.
So yeah.
Great, thank you.
Joris, can you maybe pass the mic on? Yeah, I will have time for Q&A, but I will maybe some 2 questions or something, and then yeah.
Yeah, Jan, do you know anything about the bandwidth?
It's
it's
it
taking?
all takes care of that for you. So if you have bad connection, it will you can also set that in your, like, I want this video size or maximum this bandwidth, but it will, if you don't pass that, it will do it automatically for you. So if you have bad Wi-Fi or on 4G or whatever, it will change this. It's also, in case of video, it's a codec that takes care of that. Yeah.
So your whiteboard example, was it a stream of the canvas, or
Yeah.
was it events of canvas?
It's a stream of the canvas, yeah. But
That's all I wanted.
it updates the canvas at both sides, yeah. So some use cases could be, I have some Q&A in 5 minutes as well. So some use cases, video, audio, chat, of course, screen sharing, collaborative playgrounds like we saw, whiteboard, diagram stuff like that. Everything you can do in a web browser, and you can stream, you can do it. I got a question from Australia from a client of Andrew Duncan. Yeah, can we do a call center integration? Yes, we can, but I'm reluctant to do the project because I'm not really an expert. I just made this and played around with it. But there are call, so telephone servers, centers that can integrate with webRTC. So it's actually the server, and then you can connect to it like you would connect with another web browser via webRTC and do a phone call and also pass the phone number or where you need the call to go to. So there are phone servers that also are built for webRTC. So yes, we can do it. I'm a little bit reluctant to do it because it's also in Australia. It's not really, it's far away. So if there's something wrong, so I told I like to have technical challenges, but yeah, maybe this one is too challenging for me. So, but yeah, but it's possible. So it's possible, but of course you will need maybe an expert, and maybe you come up with other cool use cases. Couple good to know stuff on Mac. Maybe you noticed when you install 21, it asks you if it can use your camera. if you, at that time when you install 21, you click no, this won't work. But you can, of course, activate it in your security settings. Just for you to know. Is it secure? Yes, it is. So all data streams are DTLS. So you maybe have heard of TLS, like emails or TLS encrypted, but it's a separate stream for data streams. And all audio and video is using the SRTP protocol. So it is secure. That's part of your handshake. You do, you also do a security handshake and yeah, pass your stuff there. More on that you can find in this link. Good to know, webRTC only use when your page is loaded in a safe environment. So it will only work when it's hosted on HTTPS or for WebSockets WSS. We are using it, or I am using it here in a local file. So I just export my HTML to a local file, or you can also do it directly in your web viewer. Just load all that code we saw in your web viewer. And luckily, a local file is considered to be secure. But otherwise, this wouldn't work. On Windows, so it works on Windows as well. But there, you really needed to export that file on your disk and then load that file in your web viewer. Because I started off just loading the code directly from my field into the web viewer. This works fine on Mac, but it didn't on Windows. Apparently, that's not secure enough, so we really needed to export using the file data file script steps. That's really easy to just to create an HTML file on in your temp folder and then reference that file in your web viewer. It's considered to be secure because, of course, it's hosted on your local computer. Also, local host is considered to be secure. So that's great. Otherwise, this would work and you would need to host your page on a web server. Would be more complicated, of course. Unfortunately, it's not yet. In FileMaker Go, I don't know why FileMaker, but of course, mobile browsers do not support the screen sharing yet. That's a pity because it would be really nice if we could do some screen sharing to an iPad, but that is not FileMaker's fault. It's just not possible. But it would be nice though. So if we go to this web page, you'll see. So on desktop, these are the desktop. They all support. This is about screen capturing, but you see the mobile browsers. None of them do. So the screen capturing is not possible on mobile devices. The camera is, but not in FileMaker Go. So it does not yet work FileMaker Go. Which is strange because it's just also a web viewer, a web browser. So it has JavaScript. I suppose they need to activate some kind of Boolean. I tested it on Go and it won't work, so it does not. Is it possible to have streams with more than two? Yes, it is. It's as easy as two-way communication. What if client 3 comes in? Just every new user will send its offer to both 1 and 2, so that offer part. And at that time, those two clients send their, they send their answer back to that, and you have video chat with 3. You just, of course, need to build your web page for that. And, but it's as easy as that. These are my resources I used. There's a really good video, Good Morning Developers. I don't know if somebody knows that, but yeah. Really fun to watch and was really informative for me. I will give, the slides are already available, but yeah, so thank you. And maybe there's more Q&A or questions. Or the mic, yeah.
Did you try it on the WebDirect?
Not yet,
No.
no. Let's do it in the, yeah, we'll need to check. I didn't yet, but yeah, I suppose it would be okay, but we'll see. I'll check later today, definitely, let you know.
The use case I'm thinking of is actually fairly simple. It's basically communicating between multiple web viewers on the same FileMaker layout. Is that kind of an overkill approach for this, or?
It is possible even in the same web browser. You can just create two web video elements and do a webRTC session in your own in one browser. So it's also possible. Somehow it knows how to relay it to the other.
Yeah, I've just got information needs to be coordinated in real time across
Yeah.
multiple.
Yeah, you could share a dashboard or whatever. Yeah, yeah, yeah.
Okay.
That's
Cool.
Yeah.
Great session. Thank you.
Yeah. You're welcome.
On what Ian said, what if you wanted like, well, if you wanted to pass something else besides media, for example, data, would that be possible?
Yeah, you can. So I only showed now video and audio, but you can have a data stream as well.
It's
It
like
ha- it-
another track, for example.
It's another track. Yeah, yeah.
Okay.
So you can have as many tracks. There's also possibility to have rooms in WebRTC. I only
Oh, you
showed
did-
you a top of
you
the
did the
iceberg, but
messaging.
there's so much in there. Yeah.
You showcased the messaging, so I assume this is using. the
No,
web.
no, yeah. The messaging was just to show you the signaling server thing in FileMaker. So this was
okay.
not WebRTC.
It was not. okay.
Sorry, yeah, for the
Okay, thank
confusion. But the first thing, the web browser, the whiteboard is actually just a stream of your canvas, and your canvas is actually just also data. So yeah, it's It-
Great. Thank you.
if you can transform it to a stream, yeah, like for games of so, yeah, that's just a stream of like the other player is there, whatever, it's a stream of data. It's also possible. Yeah.
Great.
Okay. Thank you.